Sorry about that. I've never recorded one of these before, and my computer went to sleep. So we hopefully I've adjusted the power settings such that it will adjust that. Anyways, Brent Gunning from Run approached me about kind of the things he has been working on, and I looked at that in comparison to what I had been working on, and at the time it was a very compelling story to say, okay, all this work I'm doing in a very specific fashion to support exactly what we need for crypto fights might be better handled in a far more generic fashion using something like Run, which provided a basically almost a JavaScript virtual machine sort of to handle state changes on using Bitcoin and using UTXOs as an authentication mechanism to kind of verify the authentication of making an update to an object you've got. So at that time, I kind of shelved what I had been working on, and we continued prototyping crypto fights on Run as a platform. And that was it was a good tool to help us get up and running and really define different entities, define what a fighter is within crypto fights, define what an item is, define what a battle is. And we built out a solution where a battle is actually implemented as a Run token where while it's being played out, there is a validator that owns that token and that is kind of the battle token is tied to an address or in that case it was an address, a Bitcoin address that is tied to our validator account. So players would commit their fighters to battle, players would commit their items to battle. We would use Bitcoin transaction validation to ensure that they signed off that the user was entering the battle with that fighter and they owned that fighter. And then a battle would play out. And throughout the battle, it's owned by the validator. And then at the conclusion of the battle, so when one player doesn't have any experience points or hit points left, that battle would essentially get transferred to whoever owned it. So it is an NFT. It is a token. And that token would get transferred to the owner of the fighter who won the battle. And then through some updates with the fighter, basically the fighter could destroy that battle in such a way that that fighter token gains the experience points that came from that battle. And then as things play out, as you gain enough experience points, you can actually level up your fighter, and that fighter itself is not just a static token, but it's a growing and changing entity. It is an object. It's an instance of a fighter that lives on the blockchain, and as actions are recorded on that fighter grows and changes by applying the rules that are defined in Run. And that has been very helpful. That has allowed us to build crypto fights to the point where it is today, which I believe is arguably at least from a transaction standpoint, the biggest blockchain game that's ever existed at this point. So let's fast forward now to, I guess it was spring of what year is it now? I guess spring of 2021 is when we finally released crypto fights kind of on mainnet to the public world, and allowed players to start coming in and creating fighters and earning weapons and basically interacting with the game, playing the game. Now, we've been very careful to keep it labeled as beta because this is still, although we've been able to set records for number of transactions on chain in a day, 3 or 4 or 5 or 10 million transactions is not going to get you to the point where you can support a mainstream gaming audience. Essentially, it's peanuts. It's a couple of tens of thousands or hundreds of thousands of users playing a few games each. And this is not like mainstream gaming. And throughout this process, we had to build out lots of infrastructure to support that. So Run, at its core, kind of sits on top of Bitcoin. So Bitcoin transactions and Bitcoin validation is happening, which is used to really validate an action that's being made. Does the person who made it have authority to make it? And have they signed off on the fact that their intention is to do X or Y, to attack this player in this battle, or to level up their fighter, whatever the case may be. So as in the year and a half since we've kind of gone on the main chain, there started to be a lot of lessons we've had to learn about how to scale this thing out. So there's the Bitcoin side, which Run relies on, which is all about just standard Bitcoin processing. Like, is this a valid transaction? Do I have a valid signature from the output to spend in this input to make this new transaction? At the same time, Run has kind of its own... So you can run Run without any other infrastructure at all and just spend those Bitcoin transactions. But if I have a fighter and that fighter has been in 1,000 battles, well, from just the Bitcoin level, if I want to load up that fighter and kind of see the state of that fighter, the only way I can really do that is by replaying the entire tape of the state machine, basically, of going back to, like, finding the current fighter I'm looking for, find out what UTXO it came from, find out what UTXO it came from, all the way back until the very beginning of the creation where I said, here's this new fighter. And that origin, that place where that fighter created, starts kind of the beginning of that fighter's existence. And then as I walk through every transaction forward that has every kind of function that's been called against that fighter, I start to be able to build up what its history is over time to finally getting to the point where I'm at the current transaction to figure out what its state is right now. But that's a very expensive operation. Essentially, it means any time that I'm trying to load up a fighter, the only way I can really do that from the chain is to go all the way back to the beginning and basically process the new method on it, the constructor, and then process the first function that was called again, and the second function. And so every time I want to look at, I've got this history, and that's a expanding history. So every time I go to spend that fighter into a new transaction, that's yet another bit of history that the next time I load it up needs to get calculated. Well, Run has a solution for this, which is basically a state cache, which is essentially at any point in that history, or at every point of that history, Run provided the mechanism to save the state of that trend. All the jigs is their term for these updatable objects, provides the capability where if you're running your own Run infrastructure, you can just save the state at that intermediate point. So the next time you load up a jig, you don't have to walk all the way back to the beginning. You simply have to walk back to the last place where the state was saved, which in theory is very frequently. Every transaction. So we built out a whole mechanism to have basically a Run indexer. So every time a Bitcoin transaction goes through our system, or currently also just goes through the Bitcoin network as a whole, we identify that transaction and queue it up to be processed by our jig indexer, our Run indexer. And all that Run indexer does is literally just through the Run API, or the Run SDK, I should say, it just loads up that jig. And that will look back until the last point where we've got a saved state, and it'll play it back forward, and it'll save the state of every one of those intermediate steps. This is cool, but it turns out that first of all, I guess I want to say Run is great for that, and especially in smaller pieces where there's very simple logic. If all I'm doing is I have a simple token like an ERC20 on Ethereum, and I want to have a couple methods of that I can send it to other people, and maybe I can combine a couple of them into one, and there's an initialization state where I initially mint the token, and that's it. So for something like that, it works great. But as we started out building out our entire battle logic, so in battles and crypto fights, there are, I want to say we've got something like 40 different skills in our skill tree, which these are all different actions that a player can take in the middle of a battle. So I can attack my opponent, I can heal myself, I can hide from my opponent, and there's all sorts of other different abilities that you can kind of learn as you level up. And so there's something like 40 of those. And those are all implemented as separate contracts, separate classes, separate entities in Run on the Bitcoin network. So, the little animal fun in the background. So so basically where it gets to is, so we have one process that's creating all these Run Bitcoin transactions. And then we broadcast them through our kind of Bitcoin infrastructure. So that's a separate piece. And then from there, we have to then index those things from a third piece of kind of a Run indexer, which is specifically, it knows about Run, it knows what we care about from our jigs in the Run world, and then can save the state as well as any other data that we want to index. And as we've grown, what we're really finding out with this is, although Run is super easy to build things in, it's JavaScript, every developer in the world knows JavaScript. As you start growing the complexity of these things, and as you have lots of different functions that are defined in different classes that are deployed all over the chain, well, every time I need to calculate the output of these things, I have to load essentially every bit of logic from every one of those classes. And so that means that simply me indexing one Bitcoin or one Run transaction means I have to make calls, or at least have intelligent caching set up for everything that was touched by that transaction. So every fighter that was in that battle, every item that was in the battle itself, all the methods that are defined within the battle, all of them kind of come together into this one transaction. And so where you've got the Ethereum versus Bitcoin trade-offs that says, okay, Ethereum is a single-threaded global state, and Bitcoin is essentially unlimited or unboundedly multi-threadable. When you start putting different concepts together of fighters and battles and all these different actions and skills within battles, you end up still coming back to this fairly big monolith of data. Now, it's not limited in that it's single-threaded, like Ethereum is, but it still ends up meaning if I have a token that I've introduced into our battle. So let's say we charge an entrance fee with a token, an actual fungible token that says, okay, it costs 10 crypto fights tokens in order to play out a battle. Well, if I'm an exchange, or if I'm someone who doesn't care about crypto fights at all, if I'm Fabric and I want to have exchange of value for crypto fights tokens, well, in order to determine the state of a crypto fights token within the Run ecosystem, you also, because all the transaction, all the inputs, all the logic is all together in like one blob of this is a Run transaction. In order to understand, okay, I have a token and this token is owned by this person and I can validate the authenticity of this token, the only way you can do that is by also authenticating the validity of everything else that went into that battle, which means every fighter, every item, every battle that any of those things have ever been in. So you quickly get to this same unmanageable state that basically says, my token, which is all I care about as an exchange, is now tied in with every bit of history that's ever happened in crypto fights. And that's kind of cool when it comes to the standpoint of on-chain, everything points to everything else. And so we have a complete graph of all the history that's ever happened. But if all I care about is that token, that's a lot to ask an exchange to support. I mean, essentially, everything that token, every Run ecosystem that token has interacted with now gets kind of lumped in that, okay, this also has to be validated in order to validate just simply, is this a token? Is this a CryptoPhytes token? Is this a, like, whatever the thing you're looking for, its proof is tied up in all the other things that have come before it. And this starts getting to be a real scaling problem. And it's not, I mean, as we're maintaining the state of all these things, like, we've got the state of every place a CryptoPhytes token has ever been. But there still is the aspect that says, okay, I need to load up all those current things. And so as we have, again, the example of a battle with lots of, with various fighters, and each of those fighters has many skills and everything else, like, just loading one transaction might mean making 100 or 150 different requests to kind of load up the data that helps define that. And that's where I'm kind of taking this whole concept to a new level, and taking a lot of the lessons we have learned from building on Ethereum, taking a lot of things that Ethereum did very well, and taking a lot of things that Run did very well, and building this out to release something new to the world. And so I'm going to hopefully be making a number of videos over the next couple weeks that start digging into what I've been working on for the last several months in depth. And that is the Run Metaverse protocol, essentially, which is, the name is still a work in progress. All this is very much a work in progress. But I'm really excited for what this allows for really enabling metaverse type Ready Player One, like all the stuff we've been talking about for years now. It really brings it to reality that says, I can have, in very much like the Ethereum world, I can have a token contract that I put out on chain, and that token contract is kind of standalone, has all the definitions for what interactions can happen for tokens that come from that contract. At the same time, there's mechanisms for these tokens to be spent in the same Bitcoin transactions as CryptoPhytes fighters, as CryptoPhytes items, as CryptoPhytes battles, even as social media posts, as commentary about this. These can all coexist, and they can reference each other based on what's in the transaction. But their communication between different disparate contracts doesn't get calculated in the same state machine. It basically separates everything out such that token interactions can be done on a single input-output pair in a Bitcoin transaction. So by knowing that I've got the previous state of that token built up, and it uses a similar concept to Run for that, of that there still is a concept of these are state machines. This is built from an initial state and then a transition function, something that changes that state, and then something else that changes that state, and it still builds upon each other. But removing the concept that says, but it also is dependent upon the battle, or it's also dependent upon the fighter, or whatever. Like, all of those things are independent activities within a Bitcoin transaction. And so an object can declare its intent, declare what is happening within itself. And so then if I have another contract that knows about that token. So let's go back again to the example of, here's a CryptoPhytes battle, here's a token that someone's paying to enter that battle. Well, in the Run world, the token kind of ends up needing to know about the battle, and the battle also kind of ends up needing to know about the token. Where what I'm building out here in the fixed metaverse protocol, or whatever it will be called, is essentially a decoupling of that, in that the tokens can state, I'm good with what's going on in this transaction. The person can sign off on that. But that doesn't necessarily change the state of that token at all. The battle can't say, okay, yeah, but your token, you're actually worth twice as much now. there's no direct updating of state from one contract to another. Instead, we have a number of capabilities within what an interaction with an object can do. And I'll get into this all later, but I'm trying to give a high overview of just what I'm working on here. So essentially, there's a couple of mechanisms by which a contract can influence the state of other things. And so in our example of CryptoFights tokens paying for a battle, CryptoFights tokens don't know about the battle at all. They don't even have to be spent at all, but maybe they can be spent, and saying, well, let me back up on that. So in this scenario where I've got a battle and I charge 10 CryptoFights tokens to get into that battle. So an important part of that is that the tokens get spent. And so one part of my transaction can say, okay, I've got a token output. I'm going to spend 10 of those tokens to whoever it is, the validator of the battle, or maybe it's a multi-sig, or any output that I want to do, basically saying 10 of these tokens are no longer in my wallet. They're now in a different UTXO that has its own rules for how it gets unlocked. At the same time, a battle needs to know that I've got 10 tokens, and those are authentic tokens, and those have been paid by the person who's entering in the battle. So you end up starting to build trust layers in your contracts such that the battle contract does have to know about the CryptoFights contract. It does have to know that if I get in my Bitcoin transaction, if there is a payment from a person to wherever it needs to go, I need to be able to validate that that is a real token, and that is, that is authentic, and it wasn't a counterfeit, and it's not just someone making up a fake token to get into our battle. Especially if we're going to start issuing or rewarding experience points to fighters out of this battle, or dropping NFTs as a reward for that battle. We need to know that all the entities involved are legitimate entities. But again, the battle needs to know about the token. The token doesn't need to know anything about the battle at all. All the token's doing is saying, here's 10 tokens. And that's all that token contract needs to do. Is it's the same as me sending my friend 10 tokens, but I'm sending it to the validator of this battle. Yeah, this has been kind of rambling. I got to figure out exactly how to start presenting this and how to start walking through it. But I guess there's one other thing I'd like to share just in this initial, throwing this out here. And that is one of the main things that Ethereum has that I don't think is nearly utilized heavily enough and is a really, really valuable thing, is Ethereum has the concept of events and event logs. And an event is, in Ethereum, an event is not, you can't read the value of an event from another transaction or another contract or anything like that. Essentially, events are external to the state. So you run a process that generates an event log, and that is something that you can then query from an Ethereum node. So if I run a node on Ethereum, I can go into a specific ERC20 contract, and the ERC20 standard contract has a transfer event. And so by just querying the Ethereum node, I can say, where has this item, where this token contract, where has it logged that there was a transfer? And I can query that, and that will basically give me a transaction ID where that happened. And so external to the actual state itself, I can kind of get pointers to where in the blockchain did this event happen. And I can know, the logs within the Ethereum virtual machine essentially guarantee that the logs that I get back are the ones that happened in that contract. And so taking that idea to really help enable some of these different communications of what's happening. So in our example where I've got a cryptophytes battle, and I need to know that certain amount of fixed tokens or cryptophytes tokens were paid into this to this validator, to this account, essentially by simply validating the transaction which the battle functions are in, I can see, oh, there was a cryptophytes token in this transaction. And it raised an event showing that it was transferring those things to me. And because I know the code that's in the cryptophytes contract, or the token contract, and because I trust the code that's in the cryptophytes token contract, I can know that the events that were raised from that contract can only be raised by the rules provided within that contract. Anyways, I guess there's some cool things that are in here. I've got to totally map it out how it's going to work. I got to put some documentation together. This is totally going to be a work in progress, but there's a lot here. There's a lot of cool stuff. And I want to start sharing it. I want to start getting people excited because we get to the point here where by simply knowing that there are certain realms of contracts that I need to care about, this is how we can start scaling out the multiverse to actually be working, such that if I've got a CryptoFights game, I do have a CryptoFights game. It plays out all by itself. It's got its rules built in. It's got all the logic in there that defines how a CryptoFights fighter updates and changes over time. I can, with this new approach, take a new concept of, let's say I wanted to have a Mario Kart, whatever the equivalent of we'll call it, CryptoFights Kart, that has different driver avatars, for instance. And that game is completely on its own. It lives in its own world. It's got its own contracts. It's got its own everything. But by simply saying, I also trust the CryptoFights fighter contract, and the person who's actually driving my carts are going to be CryptoFights fighters, and their experience points and their skills are kind of included in the definition of what this new kart driving game is. Well, in the run world, that could only really happen if I validated everything of the items and the battles and the tokens and everything else that was involved in that. But with this new approach, all I really need to do is my same runtime that is running the contracts for the kart game just needs to be able to add in another bit of code, which is I also want the CryptoFights fighter logic, the fighter contract, not everything else, not the battle, not the items, just the fighters. And so yes, that does greatly increase the amount of data that you need to process and the amount of state that you need to persist, but it isn't an exponential growth. It's just another realm of data. And so you get to the point where you can start having different fiefdoms of caring about what data is out there. And looking at some tools like Gorilla Pool has an upcoming tool. It might even be out right now. Actually, I think it is out right now, called Jungle Bus. Jungle Bus allows you to simply subscribe to the Bitcoin network for transactions that match a certain pattern, and to be able to both in a real-time subscription fashion and in a historical query fashion, be able to be informed about what transactions certain things match certain patterns. And so with this new protocol I'm building, essentially every contract gets tagged in the Bitcoin transactions. Now that's totally counterfeitable, but what that does allow us to do is to say, okay, something like Jungle Bus, if I want to run this Crypto Fights cart game, and it's not Fix doing it, it's someone else doing it, well, what that user would need is a subscription to all the Crypto Fights transactions that happened. So that they can know, or not all the Crypto Fights, sorry, all the Crypto Fights fighter transactions. And so by subscribing to a feed of just the Crypto Fights fighter contract, and by having the virtual machine running that will calculate the state of those fighters, I can easily have a game that pulls in Crypto Fights fighters. Similarly, if I have, let's say, a virtual world, Second Life kind of thing, where people have objects that they own, they've got property, they can decorate that property as they want, as they will. Well, there would be contracts that define that world and define what's in that world. But by subscribing to the transactions that go into defining the changes in that world, I can have my kart racing game race through that world. And I can actually see a reflection of the cosmetic changes that people have made. If they start to put a billboard on their property, and I'm racing through there, well, the engine and the racing game is going to have subscribed to this virtual world game and have all the information about what is the setting that I am driving through. Now, it doesn't have to validate all the rules about what you can do with other entities in the virtual world. All it cares about is just the contract that deals with what is the visual look and feel of my world. And so it allows you to start really crossing over realms of what is this is a public blockchain. This is, everything is recorded, everything is immutable, everything is public. So by simply subscribing to those public feeds and running the transactions through the validation engine, you have trustable proof that things are as they are, essentially. You can calculate everything that went through, that happened, that made something into what it is. And so I don't think I'm probably giving the best overview of this yet, and I think there's a lot of refinement still to come, but I'm really excited with kind of what I'm already showing we can do here. And again, I don't want this to be a closed ecosystem where we just run everything. We are still going to run our own infrastructure because we need to be able to rely on performance, and we need to rely on immediacy and lots of that kind of stuff. But I'm basically building a solution in such that you can run your own server that uses this protocol. You can subscribe to a Jungle Bus subscription that gives you the data you need. And ultimately, the read side is just a matter of pulling data that's on the chain. Now, the writing side comes from being able to sign Bitcoin transactions. So if I want to be able to change my fighter from this racing game, well, I got to have the keys that actually own that fighter. And I have to be able to essentially record changes to that fighter on the blockchain. But the reading side of things doesn't require any of that. Reading is just public data and running it through the virtual machines that are needed. I guess one more thing before I kind of close this off is that I didn't really talk about is the virtual machine itself. So I'm building everything currently in Go, but the actual virtual machines are compiled to WebAssembly. I'm currently using the WebAssembly WASI, which is WebAssembly Systems Interface, which essentially tries to give a basic Unix environment in which to run WebAssembly compiled code. So it gives you environment variables, it gives you standard in, standard out, that kind of stuff. And so by running one of these runtimes, I mean, essentially, you can build this code in Go, you can build it in Rust, you can build it in assembly script, you can build it in C or C++. Anything that can build to a WebAssembly WASI package can be used to define your contracts. At this point, I have built out a proof of concept of a simple token contract, and I built a lot of infrastructure to support all this. But it's really pretty straightforward. And I'm really excited to kind of dig in that deeper and start coming up with more interactive kind of demos of what we can do and how we can do it. And I really want to include you guys, whoever that is. At this point, I'm talking to myself, but anyone who's interested, like, this is really cool, world-changing stuff. And people have been talking about it in the blockchain stuff since, I mean, to be honest, 5 years ago, I think. Yeah, 5 years ago when I first got into blockchain. This was the dream then. And kind of set off the path to figure out how to do that. And through various processes of trying more and trying some different things and learning from that, I think we've got to a point where we can actually start putting in place the real groundwork, and not just research, but actual development of how do we make this world a reality. And yeah, I hope to not be doing this alone, but if I am, it's my passion and it's what I'm going to keep doing. So yeah, this has been long, but there'll be more to come. Thanks.